So I'm Adam Wolfe-Gordon. I'm a senior engineer at DigitalOcean, where I work on our managed Kubernetes product, which is called DigitalOcean Kubernetes Service.
Hi, I'm Varsha. I work part-time at DigitalOcean right now while I finish my master's degree. This summer, during my internship, Adam and I worked on clusterlint and integrated it with DOKS.
So we're going to talk a bit today about how clusterlint works, and how we built it, and how we've integrated it in our product. But I want to start with why we wanted to build this tool. And that story starts with something that a lot of you probably know, which is that Kubernetes is super flexible. Brian kind of touched on this in his keynote this morning, actually, that it's a very flexible tool. And this is one of the reasons why he mentioned Kubernetes is complex. It's also one of the reasons why Kubernetes has become very popular. It can suit a lot of different use cases. And it's flexible in a number of different ways. It's flexible in that it can run pretty much anywhere. You can run it on-premise, on hardware, or on VMs. You can run it in the cloud, but run your own cluster. So create a bunch of instances, turn them into a cluster. You can also use one of the many managed Kubernetes offerings, like our offering, DOKS, or EKS or GKE. There's a lot of them out there. And you can configure Kubernetes in a lot of different ways. You can use different network overlays, which are going to have deep effects on how your networking works. You can use different storage drivers, which are going to affect how your persistent storage works. You can use different container runtimes, like Docker or Containerd or gvisor. And beyond that, there's all kinds of different ways to deploy your applications to Kubernetes. There's tools like Helm that can help you with that, other tools. And depending on how you configure your Kubernetes cluster and how you're using it, you're going to choose different processes for doing maintenance and things like upgrades. And if you're using a managed offering like ours, you don't really get to choose how you do maintenance and upgrades on your cluster, because we take care of that for you. What this all adds up to is that there's a lot of ways to get things wrong in Kubernetes. And if you get things wrong, you're going to have unexpected downtime for your application. And it's also hard to define best practices and sort of say, if you do this, you'll be fine, because depending on your environment, depending on your configuration, that might or might not be true. There's kind of different things you need to set up depending on your environment to keep your application safe. So just to give a quick sort of motivating example, this is what a DOKS cluster looks like in the abstract. We build our clusters out of virtual machines, which we call droplets. And you have a control plane, which we run, and then you have a bunch of worker nodes that run your workloads. And we've decided that nodes in DOKS are essentially immutable. This kind of fits with the Kubernetes philosophy of livestock, not pets. So we provision these nodes automatically for you. And once they're provisioned, we don't really touch them manually. We're not going to go in and modify them. So if something goes wrong with one of your worker nodes and it becomes unhealthy, we're not going to SSH in and fix it, because we don't have SSH access to it. We're not going to try and fix it. We're going to recommend that you just hit the replace button. It's going to go away, and you're going to get a brand new node. And we do upgrades in the same way. So if you want to upgrade to this new teal version of Kubernetes, we're going to replace your control plane with a new teal control plane. And then we're going to replace all of your worker nodes one by one with a new teal worker node. And what this means is that at the end of an upgrade, you have an entirely new set of nodes that are unrelated to the nodes that came before them, other than that they're running the same workloads. They're part of the same cluster. So obviously, this has like a pretty deep impact on your workloads. So when customers started using DOKS and started doing upgrades on DOKS, they noticed some of these implications. One of the things they noticed is that the node names aren't stable. Because we actually replace the nodes, the new node is a new Kubernetes object. It has a different name than the old one. So if you were using a node name specifier to schedule your workloads onto a specific node, that workload is not going to be schedulable after the upgrade. Same with any custom labels that you set. We don't persist those. So if you're using labels to schedule workloads onto a specific set of nodes, you're going to have problems after an upgrade. We do provide a node pool concept with a label, so you can schedule workloads to a specific set of nodes or a specific node, but you just can't use your own custom labels for that at this point. Likewise, IP addresses change because these are new nodes again. So if you're pointing something directly at a node IP, you're going to have a problem. We recommend people use our managed load balancers for that. And your file systems aren't persistent. Anything that's on the local disk of the node is going to be gone after an upgrade. So we would recommend that people use our block storage volumes if they want persistent storage. We documented all of these things, but not everyone's going to read the docs all the time when they're deploying things. And in particular, people are going to deploy things the way they've deployed them before in different environments on different providers. They're going to use tools like Helm that are generic and don't know about the sort of subtleties of the environment that you're running in. So what we wanted was to automatically warn our customers if they had workloads that were configured in a way that we thought was going to cause problems. because we didn't want someone to do an upgrade and then discover that all of their workloads were down and have to file a support ticket and wait for us to get to it. We wanted to proactively warn them, make sure that they understood what was going to happen, give them the opportunity to fix things before we went and replaced all their nodes. So when Varsha started her summer internship this past summer with us, this is the problem that we gave her. We said, we want to build this tool that will check best practices for workloads. We want to integrate it into our product and use it to warn our customers about problems. So I'm going to turn things over to Varsha now, and she'll talk about what we built.
Thank you. So clusterlint is a best practices checker for objects in your Kubernetes cluster. It's an open source tool, and it's available on GitHub under the DigitalOcean org. The best practices that we check for can be specific to the platform the cluster is hosted on, or generally applicable irrespective of where your cluster is hosted. It's a non-invasive tool, which means that the checks that we run are run externally by accessing the objects via the Kubernetes API. Based on our experience with DOKS, we had 3 specific goals in mind before we started building it, which we didn't find was satisfied in any of the existing tools. First, we wanted to run the checks against a live cluster and not on object manifests, because actual workloads can sometimes differ from your object manifests. Hopefully, you have a CI pipeline in place to deploy the object manifests to your cluster, so that that's not the case. But we wanted the cluster operators to identify issues in one place and then go fix their configurations later on. And because we wanted to run this on DOKS, we have access to the cluster and not the object manifests. We also wanted to run some platform-specific checks. As Adam mentioned, there are some implications for workloads in the cluster, which means that there will be issues occurring in your cluster based on which platform you use. We wanted to run platform-specific checks for those issues. And because we wanted to run this tool on behalf of customers on DOKS, we wanted a static library of checks and an API to interact with, and not just a command line tool. So with these goals in mind, we started building clusterlint. How clusterlint operates is quite simple. First, we fetch all the relevant Kubernetes API objects from the cluster and store them in memory. We didn't want the checks themselves to worry about which objects to fetch, but rather focus on the operations themselves. We have several pod-related checks in clusterlint, and we didn't want every pod-related check to query for pods from the cluster. So once all of these objects are in memory, clusterlint runs the applicable checks in parallel, and each check reports some diagnostics. A diagnostic can have like a severity level, like errors or warnings or suggestion, and an actionable feedback for cluster operators. For objects that have owners, the owning object information is also provided so that cluster operators can identify the manifests they can fix their configurations for. For example, pods can have a deployment or a job as owner, and clusterlint provides that information as well. The CLI reports these results in a pretty text or JSON format, but you can also use the API to get a nice parsable structure. When we developed clusterlint, it was intended for all clusters irrespective of where the cluster is hosted. But there are some issues that will occur in your cluster based on the platform you use. Workloads that are fine on a self-hosted cluster or bare metal can be dangerous if you're using a managed service like Kubernetes based on how the service is managed for you. We came up with check groups to be able to run only the applicable checks in such cases to identify platform-specific issues. For example, on DOKS, we have the node name pod selector check. Pod selectors can be used to schedule pods on specific nodes. While this is generally harmless because of how DOKS is designed, you can have a breaking change introduced when you upgrade or recycle the node, which is why we wanted to identify and warn customers of this issue before they upgraded. Currently, we have 3 groups. The DOKS group, which consists of all the checks applicable to DOKS clusters. We run them by default before performing an upgrade on DOKS. This consists of the node names pod selector check, node labels check, webhooks. There's the security-related group, which consists of checks like identifying privileged pods in your cluster, containers running as root user. And then there's the basic group, which contains checks that are applicable to your cluster irrespective of where they are. Like if you have resources in the default namespace, or you have host path volumes for your pods. A check can belong to any number of groups. This provides the cluster operators with the flexibility of choosing what checks are applicable for their cluster. For example, we have a bare pods check, which is in the basic group and the DOKS group. Bare pods check just identifies pods that don't have owners. Usually when a pod has deployment or job as an owner, they get rescheduled after a disruptive operation like an upgrade, but bare pods don't. So we wanted to warn users of that before DOKS customers upgraded, which made sense to have the bare pods check in the DOKS groups. But it is a fairly dangerous thing to have in any cluster, so it made sense to have it in basic as well. The CLI and the API provide options to whitelist or blacklist groups and checks within those groups so that you can choose what checks are applicable for your cluster. Here's the check API for those of you looking to write a check. We have some metadata methods like name and groups, and the run method where the operation of the check is defined. It has access to all the Kubernetes objects we fetched earlier, and after the check is performed, reports diagnostics. For clusterlint to be aware of the check and which group it belongs to, checks must register themselves in the check registry. This is the example host path volumes check. That belongs to the basic group, so this check is applicable for clusters hosted anywhere. This just identifies pods that use host path volumes. Host paths are great when you have when you're trying something out in your cluster, but are fairly dangerous when you're using it in production when you know you need to persist data. This just identifies the pods, and you can go and fix your configurations to use a cloud provider volume plugin like DOKS has DigitalOcean block storage, then EBS for EKS. This is a DOKS specific check, although you could say that this belongs to some other cloud providers as well. This just identifies pods that use the host name label to schedule pods on specific nodes. We've talked a lot about the kinds of checks that clusterlint performs, but what the repo also offers is recommendations for the best practices we've identified so far and some context behind why they became best practices. For example, this is the default namespace check. Usually, if you don't specify a namespace, all the resources get dumped in the default namespace, and this can lead to privilege escalation or resource contention. So to explicitly specify the namespace is a best practice, and that's what we'd recommend in this case. But for a DOKS-specific check, while having a host name label isn't necessarily a bad thing, a workaround here would be to use the DO-provided node pool label to schedule pods on specific nodes or set of nodes, so that your pods will be scheduled after an upgrade. There are always some special objects in your clusters that are exceptions to all these best practices. Like if you have privileged pods in your cluster, you want to check for pods that are privileged in your cluster, but you also know there are some pods that need to be privileged. One way to disable checks on such cases would be to use the command line and whitelist blacklist feature, but that would disable the checks for all objects cluster-wide. So you can use annotations for clusterlint to disable checks on the specific object, and clusterlint will just ignore the object and continue to perform the checks on the clusters. This is a demo we have for clusterlint on DOKS. Let's start by creating, it's a recorded demo. Let's start by creating a cluster on DOKS. And once the cluster is created, you will have access to the kubeconfig YAML, which you can use with clusterlint like you would with kubectl or anything else. This is the repo for clusterlint, which has the binaries and the context for each of the checks. So the kube config and the context are global flags that you have, so you can always switch between clusters to run clusterlint. Since we started with like a new cluster, we would not have any resources, so clusterlint wouldn't report any issues. So let's start by deploying a bad configuration and see what issues clusterlint reports. This is the bad YAML config, which we're going to deploy into the cluster. So this is the pretty text format that clusterlint would report issues in. I think we've discussed about the bare pods issue, the resource contention, and default namespace. We can go to the clusterlint repo to find the recommendations that we have for such issues or the checks that we've performed so far, and then see how to fix the configs. For instance, we've deployed a bare pod here first. Having a deployment or a job as the owner is what's recommended so that the pods get rescheduled after a disruptive operation. So the bad config is now translated into something that would work without any issue. This is the whitelist and the blacklist option that you can use to pick what groups you want to specify. And then you can just use the JSON structure to parse and see what the owning object information is for pods and other resources. So let's deploy the bad pod again to get the issues back. The JSON structure also provides durations that we run for each check, so you can see if there are a lot more resources, it's going to take a lot more time. And then provides annotations and owning object information as well, along with the feedback. By default, on the CLI, we run all the checks on a cluster, but on DOKS, we run only the DOKS-specific checks. And that is it.
Thanks. So as we mentioned earlier, one of our goals with clusterlint was to actually integrate it into our product and use it to warn our customers if they're going to have problems before we do something disruptive. So we've done that at this point. We have an endpoint in our public API which lets you run clusterlint on your DOKS cluster and get the results. It's also supported in the DO control panel in a limited way. We always run clusterlint asynchronously through our API, just in case it takes a few seconds. We don't want to have like a long HTTP request sitting there for 5 or 10 or 20 seconds while it runs. So it actually ends up being 2 API calls, one to request a run and another to get results. You can see what the API looks like here. We have 2 requests on this slide. The first one in blue is the request to run clusterlint. In this case, we're requesting the default parameters, which, as Varsha mentioned on DOKS, is just the DOKS specific group. But you can specify which groups you would like in the payload of that post request if you want to, so you can run any of the checks that clusterlint supports. What this returns is a run ID, and you can use that run ID to fetch your results later. We keep the results around for about a week, so if you want to run clusterlint at a regular cadence and kind of track your results or something on your cluster, you can do that. The second request here, the one in orange, is the request to get the results. In this case, we're requesting the results of just the last run that completed. So that's what we get. You can also use the run ID to request results of a particular run. In this case, we have a badly configured admission control webhook in our cluster. This is one of the #1 problems we've seen customers have with upgrades, is they have admission control webhooks that prevent some of our managed components from starting, so our CNI, for example. And that makes an upgrade go really badly because you don't have networking when you start up your new nodes. So that's the diagnostic we get here. We do also run clusterlint before you request an upgrade, if you request an upgrade through our control panel. And you can see on the slide, this is the dialog box that pops up if it returns any warnings. So this is the same cluster from the previous slide. It's got the admission control webhook problem. And it gives us a couple of options. For one, it gives us a link to the docs, so you can actually see how you might fix this problem. We're not just telling you there's a problem, then leaving it up to you to fix it. There's also a rerun button, so if you go and fix your config really quickly, come back, you can hit the rerun button and see the new results. And we do provide an option to just bypass the check and say, yeah, I'm fine. If you're really confident that it's not going to cause problems, or if you just want to see what happens, you can click that box and still proceed with your upgrade. We are still working on clusterlint, and we have a few things in mind that we would like to do. For one, we'd like to add more checks. We definitely don't cover everything. There's a wide array of Kubernetes best practices, and we only cover some of them. Another is better integration into our product. So as I mentioned right now, we run it only before manually triggered upgrades automatically. We'd like to run it also before our auto upgrades. So if you set a maintenance window, we will do auto upgrades on your cluster. Right now, we don't run it in that case, but we'd like to run it and maybe send you an email if you're going to have problems with the auto upgrade so that you know ahead of time. We'd also like to run it before other disruptive operations like replacing a node or even scaling your cluster, something like that. Ideally, we would run it periodically and just report the results somewhere so you have a persistent place you can go and see, maybe even track results over time, something like that. Finally, we thought a lot about how to do Kubernetes version-specific checks in clusterlint. Especially for the upgrade case, we'd like to do checks for the next version before you do the upgrade. So you can see, am I using resources that are deprecated in the next version? Am I using fields that have changed their meanings or their names in the next version that my workloads aren't going to behave as I expect? This is a little bit tricky because the Kubernetes API and client code do some translation for you. So if you request objects from one API group and they've migrated to another API group, it will do that translation. So it makes it a little bit hard to actually tell whether you're using anything deprecated. But if people have ideas for how we can do these version-specific checks, that's something we'd like to hear.
Before we started building clusterlint, we looked at some of the existing tools. There are some great manifest-based linter tools like kubeval, kubelint, and Copper, which are great to use in your CI/CD systems to check if the YAML is sound before deploying onto the cluster. Clusterlint identifies issues with your cluster after the workload's been deployed. So they could be platform-specific, or there's something that you wouldn't, the YAML would be sound for, but would create an issue later on. If you're interested in security checks specifically, then there's KubeBench. KubeBench can be deployed as an in-cluster tool as a workload itself, and it's going to start reporting issues after you deploy it onto your cluster. Clusterlint is different from that because it works externally, runs the checks on objects by accessing the Kubernetes API. If we want to focus on workload health and get a dashboard for it, there's Polaris. We intentionally did not want to focus on workload health because there's the Kubernetes dashboard and other observability tools out there to give you this information. In terms of the checks, Popeye comes closest to clusterlint. I think the difference between the two tools is that clusterlint also has this ability to provide platform-specific checks.
So finally, before we wrap up, we would love help with clusterlint. And assuming that most of the people in this room use Kubernetes in some way, there's a couple of ways that most of you can help us if you're interested. One is to just give it a try on your clusters and let us know if it doesn't work or if it has surprising results. If you have false positives or false negatives, things that you didn't expect, that's something we'd like to know. The other is we would, as I mentioned before, love to have more checks. And especially if you're running in an environment that's not DOKS, we would like to know what are the specific gotchas in those environments. So if you're using EKS or GKE, or you're running on-prem on hardware or something like that, we would love checks for those environments to add check groups to the tool that cover those environments. I think some of the checks that we have for DOKS are probably applicable to other clouds, so people could start with those and sort of let us know what they think is applicable. We would love pull requests or issues. It's all up on GitHub, so yeah, let us know what you find. And that's all we wanted to say today. You can see on the side our email addresses if you want to get in touch. There's also another link to the GitHub, so go check out clusterlint. And I think we've got time for questions. We'll also be around the conference, so come and talk to us the rest of the day. Thanks.
Thanks, Adam and Varsha. So I'd like to remind everybody, you can go onto sketch.com and review the talk. That would be really great if you could. And then if you have a question, if you raise your hand, I'll bring the mic over to you.
So a couple related questions. Can I write my own checks if there are some things internally maybe that I just don't want to put in the public repo that we do? And is there a way to share checks? Do they just get checked into the repo?
Yeah, so right now, the check library is totally static. Checks register themselves when the tool starts, and it's all static. It would be interesting to maybe use like Go dynamic libraries for this to provide that ability to do like really org-specific ones. But it's not something we've implemented right now, so it's an interesting idea.
Yeah, hi. Do you think it'd be out of scope to check for under or unutilized resources like services with no endpoints or ingresses that point to non-existent services or PVCs that aren't in use?
Yeah, we do have that kind of check. I don't think we have one for ingress or services, but we have some checks for tidying up your cluster, like unused PVs or PVCs or secrets.
Hi. Over here. So I have a really quick question. So just about optimization. I saw the linting. It seemed like a relatively small, example cluster. What would you say the standard run time would be for something that maybe is, because the linting is going to be done after you've applied the configurations, right? It's going to be done, what am I doing right now? So it's going to be generally, from what I see, used for enterprises and organizations that are pretty deep in already and need to see, like, where are all of my problems, right? So I guess that's where optimization becomes a big deal.
Yeah, so I would say the slow part of clusterlint is fetching all the resources from the API server. Once we've done that, the checks run on in-memory objects, so they're pretty fast. If you had a huge number of pods, it might take some milliseconds to iterate over them, but in general, it's pretty quick. I think that in terms of optimizations, being able to limit it more to like a namespace or a particular set of objects, that might be a helpful thing. Sure. Anything that we can do to kind of reduce the number of calls we have to make to the API server would be helpful.
Absolutely. Okay, thank you very much.
Hey, so the tool seems to allow you to check what you've already deployed. Do you have any plans to make it where it will lint, like effectively before you deploy it or immediately after a deploy and say, nope, that was bad, and roll it back for you?
So we wanted to run this on live clusters, so we wanted to run the checks only after the deployment, but There are some YAML linting tools already out there to check that, but that wouldn't catch issues like resource contention if you're dumping all your resources in the default namespace, for which you have to deploy the workloads.
Right, so I get that, but what I mean is once I deploy and the clusterlint catches it, are there any plans to make it where you'll just remove that build and say, you introduced a root user in an application that's disallowed, similar to something like an open policy agent, I guess?
Right. I think that's an interesting idea. I'm not sure if clusterlint would be the best tool for that. I think probably admission control and, like you said, open policy agent are sort of better tools. The things that run in the cluster are a bit better for doing that. Yeah, and you could build it into your CD pipeline with clusterlint. I think clusterlint is really more focused on like proactive identification of things that aren't problems right now, but will be problems in the future. So really identifying like things that are going to break when you do something disruptive, or if you lose a node, or things like that.
I think
Hi, thank you for doing this. I was wondering for the reporting section, have you guys thought about integrating it with like some sort of test framework, like reporting with like TestNG, for example?
Just in terms of like providing nicer or more standardized output format, you mean?
Standardized open format, being able so that we don't have to reinvent the reporting system just for this particular, just for clusterlint.
Sure. I think it's not something we thought of, but it's an interesting idea. Each of the checks, like we showed in the API, actually just returns a structure. So the outputting of that information is decoupled from the actual check. So it would be fairly straightforward to add another output format if people wanted it. Right. Yeah, I just mentioned the grouping of the checks is a little bit like grouping of test suites. It's a little bit different in that a check can live in multiple groups and it can also live in no groups. If you have a check that's like kind of an outlier, it doesn't have to be in a group. So it's a little bit different than that scenario, but yeah, it's similar.
Any more questions? Nope? All right. Well, thanks again, Varsha.
Thanks, everyone.